But here's the problem. While you can clearly see the magnets are being pushed by the influence, it takes a very abstract thinking process to not recognize that what you just experienced is a pull. That is what a pull looks like. Can I describe the mechanism that creates a pull? No, I cannot. But what I can do is I can clearly show you an observable pull scientifically. If you can't see this, I mean, how do you see the push? That's a push. This is a pull. So you're asking yourself, Paul, how do you know that what you're seeing is a pull? How do you know that you're not viewing a push? The reason why I know what I'm saying is a pull is because of orientation. It's all about orientation. Right now, these magnets are orientated. If you notice that the magnets push away from each other, it's dependent on the orientation of the magnet. Because this particular type of magnet has a cut. It has been manufactured in such a way that it creates a particular influence based on its actual orientation. Because the electromagnetic fields line up in the universe. Whatever generates the electromagnetic field inside of the matter itself has an orientation that is aligned to the object. And that is why orientation is important. Because as long as this magnet, because they're circles, as long as they're in this particular orientation, then it will always push. They will always push against each other. So what I'm going to do to help you understand what's going on is I'm going to give this some coordinates. Okay. I'm going to give this thing some coordinates. So toward and away from the camera is going to be the z-axis. Basically, from here to here, because we live in 3 dimensions, this is the z-axis, right? So this is the x-axis, and this is the y-axis. Now, I'm going to show you something very interesting when it comes to magnets and attraction that a lot of people don't ever truly understand because they don't actually sit down and play with magnets. Okay, let me make sure that they're aligned correctly. Okay, we got to push. And again, this is the z-axis. Now, my magnets are going to repel each other, right? I'm going to rotate this magnet 180 degrees on the x-axis. This is why quantum physics describes force interaction, the charges, as clockwise and counterclockwise. See, you don't recognize this if you don't play with the magnets. If you just listen to what is being said and you don't really put any energy into looking at the actual observations in nature, you miss this kind of stuff. I just rotated this magnet 180 degrees. It's not going to push. It's going to pull. It's going to pull. If I rotate it back 180 degrees, it's going to push. The orientation is very important. This is the reason why Newton's law of gravitational attraction, I can't quote it accurately, is defined as creating a force from the center, as if the masses are at the center. The mass attraction comes from the very center. The reason why the mass attraction comes from the center is because gravitation is not influenced by orientation. Magnetism, when it comes to gravitation, we observe a uniform, indiscriminate mass attraction. That means that no matter how many directions are changed, you change the orientation of an object, it will always create a pull, not a push. The magnets, I can illustrate attraction with the magnets as a pull because of the dualistic nature of electromagnetism. But if these magnets were mass attraction, as they got close to each other, they would attract only. If I rotated this magnet 180 degrees, and it was mass attraction, when I moved this magnet toward this other magnet, because it would be operating under gravitational forces, it would pull toward the other magnet. But it doesn't, because gravitation is indiscriminate mass attraction. I can illustrate gravity very easily for you by simply dropping the magnet. I can do this experiment over and over again until I'm 100 years old. And I promise you that every time I drop a magnet, it will always move toward the center of the earth. Because as I said, from the camera to the table is gravitation. It's the z-axis. If I take a magnet, this magnet from above, I can still generate a z-axis attraction or repulsion because we live in 3-dimensional geometry. I just reversed the field, and if I did this correctly, the magnet should repel because it's going to operate on the actual, it's going to operate on its behavior. It will always do that 100% of the times, all the time. This is observation. I cannot say that these magnets will not repel. I cannot say that these magnets will not attract, because they're not going to listen to what I have to say. They're going to behave the way that nature describes them. And that is why gravitation is a... that is the reason why gravitation is a push and not a pull. So, I'm going to show you how gravity works using illustrations. That's the reason why I had a paper, because I can show you the forces. You can ignore the theoretical illustrations, but you have to remember that the illustrations that I'm about to show you are influenced by the observation of electromagnetism. Because just like we can see that a magnet can both attract and repel, we always see that gravitation pulls toward the center of the earth. Always, 100% of the time. You can change the mentality of it in your own mind and change the orientation so that that's not the case, but that's always the case. And this is basically how it works. The earth, this is earth, has a gravitational attraction that goes out in all directions. This gravitational attraction pulls everything toward the planet. Everything that has mass is pulled toward the planet. The sun has gravitational attraction. All of the bodies in the solar system are pulled toward the sun. This is how it works. So, what happens is, there's two basic forces in our universe. There is, to use these again to illustrate this, there is a motion that is rectilinear, basically a straight line motion, and then there is a motion that is curvilinear. There's a rectilinear motion and a curvilinear motion. That's pretty much how it works. The same force of attraction that is operating on this magnet, that causes this magnet to spin around this other magnet because of the geometry, circular geometry, is the same reason why the moon orbits the earth. Because the force that I'm generating is a rectilinear force. It's a rectilinear force. The force that I'm exerting on this magnet is rectilinear. But the influence of the electromagnetic attraction creates centripetal force. You notice the first thing you see is centripetal force. Why is the moon orbiting the earth? Centripetal force. The indiscriminate mass attraction of the earth and the indiscriminate mass attraction of the planet causes a spin. The earth is at the center because the mass is greater, and the moon is orbiting the earth because its mass is lesser. The moon is actually trying to move away from the earth, but it can't. This is what Newton outlined. Newton's law of universal gravity has outlined this. Newton described the behavior of the movements of the celestial bodies in the universe, and as well as the movement and the behavior of the quantum. He did this by observation, not by sitting down doing mathematics. He was a great mathematician, but he was more concerned with what he was observing opposed to what the numbers on papers was showing him. He made sure that he took time out to make sure that the math matched the observation. Relativity and quantum mechanics, they're so busy looking at the numbers now that they're ignoring the observation, because what they are observing doesn't even comply to observation. You cannot directly observe the quantum because it's too small. So they're putting as much faith, they're putting 100% faith in the math, but they know for a fact that math is not observation. So gravity is a push. That is what we believe. I can clearly show you with these magnets that, in fact, gravity is a pull. If gravity was a push, this is the behavior that you would expect to see. Notice how it vectors away. How is the sun orbiting the Earth if the orbit is vectoring away from the center of the attraction? Because the field strength from these magnets comes from the center. It works its way outward. Inversely, that means that as the distance between them is reduced, the distance between them determines the field strength. The further these magnets are, the electromagnetic interaction between them is dropping. The further I move them apart, the more it drops. The closer I bring them together, the stronger the field gets. The stronger. Right now, they're actually pulling on each other. The only reason why they're not touching is because of the opposition of my hands. The force of my fingers is greater than the force of their pull. So there's a strong field between these two magnets that you cannot observe.